Welcome to EDU World Space.
This is chapter 21, problem number 92. We're given a one-dimensional row of positive ions, each with positive Q charge and a separation distance d. So let's assume that this is a coordinate system. This is the origin. We have an ion Q placed at x equals 0, and we have another one, the same magnitude, placed at x equals d, and another one is placed at 2d, and then 3d, and so on. And this row is going to infinity. So we have infinite amount of positive Q charges here on the positive side of the axis. Now in part A, we're putting an electron here at x equals negative d, and we're asked to calculate the magnitude of this force and discuss the direction of this force. First of all, acting on the electron, right? So first of all, these are all positive charges. They're all going to attract the electron, which means the net force acting on the electron is always, well, it's attractive, right? So it's always in the positive x direction. Now let's discuss the magnitude. So first, let's talk about the force that the positive Q charge that is located at the origin exerts on the electron. So it's going to be, we're just discussing the magnitude here. So Ke, the first charge, times the second charge divided by the separation between the two, which is d in this case, right? D squared. So this is the force exerted by the one at the origin. So then we have infinite number of these, right? Let's try to add a couple of terms first. Now we have the second positive Q here, located at x equals d. So it's going to exert this amount of force. In denominator, we're putting the distance between the two, right? So from here to there is 2d. Square that. So now third charge, KEQ, now you know the trend, right? Over 3d squared, and so on, right? This goes to infinity. I'm not going to write each and every one of the terms. My lifetime wouldn't be enough for that. So then the force that we have is basically, it looks like KEQ over d squared, 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared, and so on, right, to infinity. So this is like an infinite summation, right? And as you can see on the hint of the problem that is given to us, this looks like 1 over n squared, and it starts from 1 and it goes to infinity. And this value is given to us as pi squared over 6. So then the force is going to be equal to KEQ pi squared over 6d squared for this case, right? Perfect. Now for part B, the only difference, everything remains the same. The only difference is where we put the electron. Now the electron is placed at x equals negative 3d, okay? So what this is going to affect is that we still have the force KEQ, I'm talking about the magnitude of the force exerted by the first ion at the origin. Now we have 3d squared, right? Because that's this distance between the two. Then the second ion is going to exert 4d squared much amount of force. And then the third one is going to have 5d squared, and so on, right, to infinity. Then what we have is, now we're not starting from 1 over 1 squared, but we're starting from 1 over 3 squared, right? So force is KEQ over d squared. Now we have 1 over 3 squared plus 1 over 4 squared plus 1 over 5 squared, and so on. So let's look at what this term means, right? This term means KEQ over d squared. If we write the expansion starting from n1 to infinity, right, 1 over n squared, then we're including two terms here, 1 over 1 squared plus 1 over 2 squared. Well, we might as well subtract them, right, to get to this term here in parentheses. So this is what we would have, correct? And we know that this expansion equals to pi squared over 6, and here 1 over 1 plus 1 over 4, it's going to be 5 over 4. So now the force is going to be KEQ over D squared pi squared over 6 minus 5 over 4. Still attractive, right? The direction doesn't change.